Today, in the first part, we will see two things. Number one, how to prepare the milk sample for its chemical analysis. And number two, how to analyze presence of glucose or disaccharides in the milk, and number two, how to check the presence of proteins in the milk. And then in the next session we will go through for other substances. So starting from some introductive points related to milk. The first thing is that milk is a common source of nutrition in almost every society of the world. And particularly, it is a source of nutrition for the children up to a particular age. Up to a particular age, they fulfill their nutritional requirement only by the milk. Now, why the milk is used as a source of nutrition? Because of many reasons. Number one, easy to obtain, easy to intake, no need of any particular preparation, easy to digest, and a good source of the different nutritional components. And particularly among the different components, calcium and phosphate is the most important source of the milk. And in many cases, particularly the growing age, particularly during pregnancy, particularly during and after the illness, under all these conditions, milk is used as a good source of energy and as well as a good source of calcium and phosphate. Usually, the milk is obtained from cows and buffaloes. But there are other sources of the milk as well, including the sheep, the goats, the camels. Their milk is also used. But the common source of milk is cows and buffaloes. Now it is available in the other forms as well, like in the form of dried milk, in the form of evaporated milk, in the form of condensed milk, so many different ways. Similarly, milk is used to prepare the other substances as well, and they are commonly grouped as dairy products, including cheese, including yogurt, including laban. All these are also fats are prepared from the milk. So many different products are also prepared from the milk, and they are known as dairy products. Now, one important thing here is that for a newborn baby, the main source of nutrition is the mother's milk. And this mother milk is very important, not only to give the nutrition to the baby, but it also develops a bonding, a relation between the mother and the baby. And particularly the milk, the mother's milk during the early days, during the starting days after the childbirth, early period, it is very important for the baby. And the first or the earliest milk which is ejected out from the mother's body, that is known as colostrum. that is known as colostrum. And this colostrum is very important for the baby because it contains large number of antibodies, gamma globulins. And these antibodies or gamma globulins, they provide the baby the initial protection, because the baby is just, it comes out into the world and it is exposed to a lot of microorganisms, so its immunity is increased, its resistant power is increased by the presence of these gamma globulins or antibodies in the initial milk of the mother, which is known as colostrum. In addition to the colostrum, the human milk or mother's milk, it contains another important protein called taurine. And this taurine, it is very important particularly for the nervous tissue. But unfortunately, this taurine is not found in the cow's milk. So those babies who unfortunately cannot get mother's milk and they have to feed on the cow's milk or buffalo's milk, they are deficient of the taurine because no taurine in the cow's milk. Similarly, the cow's milk contains another group of proteins which are derivatives of phenylalanine. And these proteins which are derivative of the phenylalanine, they are not properly digested by the human beings because the enzyme required for their digestion is not available. Therefore, it forms an undigestible curd. Undigestible curd-like material. This is the reason why now the WHO or the World Health Organization, it is emphasizing worldwide throughout the world to promote the mothers to feed their babies at least for a period of first 4 to 6 months or first 1 year, because the mother's milk can provide all the required material to the baby required for its growth. The cow's milk or the buffalo's milk, whatever good it is, it cannot provide all these nutritions. Now, after this brief introduction about the milk and the milk-related things, let's consider that how to prepare a sample of milk to analyze it chemically. In order to analyze it chemically, we will prepare a milk sample, and for this purpose we will take 10 ml milk. In this 10 ml milk, we will add 10 ml 1% acetic acid. So 10 ml milk plus 10 ml 1% acetic acid, and then add 20 ml distilled water. So 10 plus 10 plus 20, it becomes total 40 ml. So 10 ml milk sample, 10 ml 1% acetic acid and 20 ml distilled water, all mix it together in a beaker. So take a beaker like this, add first 10 ml milk, then 10 ml 1% acetic acid, then 20 ml distilled water, and then all these three shake for some time so that it will mix properly, and then wait for a period of 5 minutes. After 5 minutes, then you have to filter out this solution. Mix, wait for 5 minutes, and then filter. How to filter? In order to filter it out, take a filter paper and first fold it like this. First fold, then second fold, and then open it like this in a funnel shape. And then take a funnel and a beaker and put this filter paper inside here, and then add your solution here. Add the solution here and then wait. Through the filter paper, the solution will dropwise, gradually it will filter out, and within 10-15 minutes you will get a filter out of the solution, and the thing which is left here on the filter paper, the solid material, that is said to be the residue. The part of the solution that remain here on the filter paper, that is called residue. Its name is residue. And what you collected here in the beaker, that will be called filtrate. So milk filtrate and milk residue, two things will be separate out. Now from this filtrate that you collected in the beaker, now you have to perform your chemical analysis. So this first part of preparing the milk filtrate is completed as you get the filtrate inside the beaker and the residue on the filter paper. Once you collect it, now first you analyze this solution or the milk filtrate for the purpose of disaccharides like glucose-like material present in it. For this purpose, in a test tube, take 2 ml milk filtrate, and add 2 ml Benedict's reagent. So 2 ml milk filtrate in a test tube and add